All right. This is another pretty short section. Okay, magnetic field. I put little jokes in some of the titles for some of my kids because I feel like they're gonna get bored if I don't. Okay, um, but this is magnetic field. Now this vectors activity I actually think that is probably best for you to do on your own. I'm not going to go through it here just because what you're going to notice is you're going to notice some trends with how the magnetic field interacts with bar magnets, right? Whether which pole cause magnetic field to point away, which pole causes it to go towards it, okay? And you're going to notice that's actually very similar to electric field, okay? But I want you to just, I think you should discover that on your own, okay? So, I have compasses and bar magnets for my kids. I would suggest that you try that. There's plenty of demos I think you can do online too that show you kind of how it works. So I would suggest that you do that on your own instead of, I'm not going to go through that. I would suggest that you just go through that on your own, okay? Okay. You zoom back in here. Okay. These examples, I'm gonna do this really weird, okay? I'm gonna teach you the right-hand rule first before I do these examples. So I'm actually going to skip the examples for right now and go to this page, to the next page, like the back of that page, because here's what I'm gonna do. I'm gonna teach you this part first, then we'll go back to those examples, then we'll come back to here, and then go back to those other examples, okay? I know it's confusing. I probably should have reordered it differently. I apologize. I didn't even think about it, right? I do this all the time, and so I don't really think too much about it. So let's just go ahead and start here. So we're going to start with the right-hand rule, okay? This is one of the 4 right-hand rules that you're going to learn this unit, okay? If you have a wire, okay, that is creating a magnetic field, so their current carrying wires can create magnetic fields, okay? If you have a wire that's creating a wire that's carrying current and it's creating a magnetic field around it, you can determine the direction of magnetic field around it by using the right-hand rule, okay? So first off, when you do the right-hand rule, okay, we call it a grip rule or a grasp rule, okay? You basically do this, right? Thumbs up, okay? And what happens is you actually wrap you actually kind of wrap your hand around the wire, and then your thumb points in the direction that the current's flowing, and the B field circles around the wire, okay? So in this example, right, this big arrow coming up here is your current, okay? And then this circle right here, okay, I'm drawing it really poorly, is your B field, okay? Your thumb points in the direction of the current, okay? And your fingers point in the direction of the B field. Does it make sense? So to give you, in general, thumb, okay, curls in direct, not curls, sorry, that's what the fingers do, okay? Doesn't curl. Your thumb, can it curl? I'd be kind of concerned if it can. Points in direction of current. Okay. Then your fingers curl in direction of B field. And notice again, B field is circling. Okay? It always circles current carrying wires, okay? Okay, so let's do an example, right? By the way, this type of notation, you're going to see this dots and X's notation. When we say that there's a dot, right? That is out of the page, okay? And then the X's mean into page. Okay, so the dots mean out of the page, into the page. Think of it like an arrow, okay? If you have a bow and an arrow, okay, and you let it go, if you're behind the arrow, you're going to see the tail of the arrow flying away from you. Okay, into the page, okay? If you see a dot, like if you're in front of the arrow, okay, then you're going to see just the dot of the arrowhead heading towards you, and then, you only see it for a brief moment, and then there's going to be silence, right? But you get the point, okay? So let's figure out using the right-hand rule. And remember, it has to be your right hand, okay? You have to use your right hand. So get out your right hand, okay? And you are going to look goofy on the test doing this, by the way. I'm going to get a kick out of it for my kids. Hopefully anybody else does too. But So here's your wire. Okay. Oh, current is going out of the page. Okay. So thumbs up, right? Gig them, right? Okay. And then our fingers are going to curl in the direction of the B field. So if my thumb's pointing up, my fingers are going to curl in the direction of the B field. So it's going to go, what is that? Counterclockwise. Okay. So it'll go counterclockwise. Okay. Okay, and you get the point, right? It's just going to go, it's going to look kind of like that. And the magnetic field is actually kind of getting weaker as it goes, right? So there's a little bit less deflection on the other ends, okay? And I'm not drawing it super well. I don't care, okay? Okay, here we go. Okay, you get the point, right? You see that it's curling. You understand that it's going clockwise, okay? If we have the current going into the page, then I'm going to do thumbs down, which is what a lot of people do while they're taking my test. They give me a thumbs down, okay? And you'll notice that my fingers are going to curl now clockwise, okay? So my thumb goes down, my fingers curl clockwise now, okay? So then we would draw the clockwise magnetic field, okay? Okay, and then again, you would just, do it still a little bit more, okay. Bum, bum, bum. Okay, you get the point, right? I really didn't have to do all of that, but I did because I care, right? Okay. So you can see that it's going clockwise, okay? Now let's bounce back to that other page really quickly and talk about the other right-hand rule. This is for a solenoid. Do you know what a solenoid is? A solenoid is like a cylinder, okay? It's like a hollow cylinder that has a wire in it, right? So it's like a cylinder, okay? And it's kind of got like a wall, and then it's like a hollow space, and it's got a wire running through it, right? That's one way to think of a solenoid. And what happens is in that coil, you can run current through that coil, okay? And so what happens is your current actually ends up circling because it's in the coil, right? So for a solenoid, okay, this is specifically for a solenoid, for magnetic field inside of a solenoid, it's actually reversed. The line now is your B field, because your B field is straight, and then this part right here, okay, is your current, which is circling now. So your thumb, okay, points in direction of straight B field, okay, and your fingers curl in direction of the current, okay, in coil, okay, and it's circling. Oh, I should also note that too, circling, okay, it's circling because it's going around the coil, right? Okay, let's flip back because we're going to look at some solenoid examples now. We have a solenoid here. So now, instead, my fingers are going to curl in the direction of the current. My thumb is going to tell me where the B field is pointing inside the solenoid. Okay, it doesn't tell me everywhere, it just tells me where it's inside the solenoid. So we go into the page above on the top part of the solenoid and out of the page below. So I'm going to go into the page on the top, okay, and then out of the page on the bottom. Oh, look at that. Where's my thumb going? It's going to the left, right? So our magnetic field inside the solenoid is going to the left. So it's actually going to even go out here too a little bit. So boom, boom, boom. Okay, you get the point, right? Now what's going to happen on the outside of the solenoid? So what's actually going to happen is outside of the solenoid, the magnetic field lines are going to loop around and come back into the solenoid. So what's going to happen is it's almost like this is like a ride at Six Flags that everyone wants to ride, okay? And what happens is they get on, they ride it, and they're like, again, 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 and they go back in line, okay? This is basically kind of how it works, right? So what's going to happen is they're going to basically loop back around, okay, to get back on the ride, okay? And they're basically going to, okay, okay? You can see that basically, right, they're coming out of the solenoid, going all the way back around into it, and they're going to keep doing that over and over and over again, okay? Okay, so they're going all the way around, they're coming back in line to get onto the solenoid ride, okay? Now, if we look at the other one, right, again, dot is coming out of the page, X is going into the page. Okay, so then, oh gosh, I have to turn my paper, or I have to stand up for this. I'll just stand up because I do this because my kids think it's goofy, right? Okay, so then I would take my fingers and they go into the page on the bottom, and then they curl around and come out of the page. Oh, where's my thumb going? It's going to the right, right? Okay, I'm not AI generated. I don't have like another thumb pointing to the left or up or whatever, right? I just have my one thumb, okay? Maybe one day I'll get more, okay? But on the inside, okay, okay? And then it curls back around, right? They want to go back on the ride, okay? So everybody wants to take a ride on the solenoid ride, okay? Ooh. I'm terrible at drawing these, gosh. But I'm also like trying to get through them fast because I want to go home and play Destiny 2, okay? Oh, this way. Okay, and then... It's not perfect, but, you know, you get the point, okay? Oh, gosh, oh gosh, okay. So you get the point, right? It's coming into the solenoid here, going all the way through, and then it wants to go back around and get on the ride. It goes in, comes back around, wants to get back on the ride, okay? Magnetic field points away from positive charges and over toward negative charges. So if you did the bar magnet activity earlier, you should see this trend where the magnetic field, okay, points away from north and then towards south, okay? So the magnetic field should point away from the north and then towards the south pole, right? Just like positive and negative charges, okay? And then finally, the algebraic symbol for magnetic field, we kind of already did this a little bit. We called it B, okay? In the previous video, we called it B. And then the units for magnetic field are a unit called Teslas, okay? Not like the car, okay? These ones you can actually submerge in water and it should still work, okay? All right. That is magnetic field. All right. We really had a field day with that one. All right. See you later.